Hello, and welcome to our 7th lecture in Module 4 in our Summer Cognition series. Today we're going to be talking about the ways in which we measure working memory capacity and the types of psychological variables which working memory capacity has been shown to be predictive of in the relationships therein. So we'll take a look first at the ways in which we try to measure working memory capacity, because it is different from the kinds of tasks we talked about when we talked about passive short-term memory. And then we'll get into talking about how working memory capacity is a powerful predictor of behavior. So here we are in our full discussion of working memory. We're going to cover these two topics in this lecture, and then in the next lecture we'll finish up this module with discussions of the neurobiology of working memory and how traumatic brain injury affects working memory capacity. But first, let's get through this topic today. So first of all, there is some controversy over what working memory capacity is and what tasks used to measure it really reflect. So there has been an enormous amount of work done in this area, and there are as many tasks reported to measure working memory capacity as you can possibly imagine. Unfortunately, trying to tease apart what is working memory versus sort of the passive short-term memory we talked about previously is an issue. So those classic span tasks used to measure short-term memory capacity, like digit span, word span, letter span, do not really effectively measure working memory capacity, because when we're talking about working memory, we're talking about your ability to hold information and operate on information at the same time. So there's a component of holding onto information, as well as a component of working with other information. So things like trying to block other information, trying to handle a task, plus trying to remember what you're supposed to remember. So in this instance, what has been developed are what we call complex span tasks. So these include things like the operation span, or the O span, the reading span, and the rotation span. And so we can take a look at each of these. So in a simple span, you would be just given those letters in a row to try to remember. In a reading span task, you'd be asked to determine whether or not the sentence makes sense, and then try to remember the letter, and then make the judgment about the next sentence, and then try to remember that letter. So the task is still to remember BNKJS, but you're still having to accomplish that reading task at the same time. So this adds a layer of operations to that, when in this case it's a reading operation. And the operation span task, instead of verifying whether or not the sentence is correct, you have to verify whether or not a math problem is correct. So is 3 times 1 minus 1 equal to 3? The answer to that is no. That's equal to 2. So you would say no, and then you would try to remember B. And then is 10 divided by 2 plus 1, does that equal 6? Yes. Then we would try to remember N. So now remember BN, and etc., etc. You can experience this for yourself if you go to Timothy Bender's website he's at Southwest Missouri. He has some really great cognitive demonstrations, and you can actually do the operation span task. There are a variety of these versions of this task, but this is one you can do online and at least get a sense of how it's working, how this works, and how difficult it is. So rotation span is also unique. There are a couple different tasks. You have to determine if this is a letter that is rotated, or is it the mirror of a letter that's been rotated. So you can see the R here. This R has been actually just rotated 90 degrees, whereas this G is actually the mirror of a G, and then that's been rotated. So that's the judgment you make as the operation. The memory portion of this is to remember the direction of these arrows, and then you have to indicate which direction those arrows were in. Again, another pretty complex span task. So these are also known as what we call storage plus processing tasks. So you have to store information, that is the letters or the directions in the rotation span, plus process other information. So dealing with the direction of the letters, dealing with the sentence, or dealing with the math problem. So as part of this, Randy Engle and his students at Georgia Tech have developed what's called the Online Working Memory Lab, or the OWL Lab. And in this instance, they're trying to determine whether or not you can measure things like operation span in a completely online capacity rather than where you're watching somebody in the laboratory. And so they developed an operation span task. So they have to remember a letter, solve this problem, remember another letter, and then enter the number of the order of these letters on this screen. In this task, this is the symmetry span task. The participant is to remember the location of this red square, then determine if this stimulus is symmetrical or not down the middle axis, and this one is. Then remember this location, so then they would enter 1, 2 in these locations. So those are the operation span and symmetry span tasks that were developed as part of this. In this mental counters task, subjects have to keep track of these 3 lines here. So each line starts with a value of 5. So this one's worth 5, this one's worth 5, that one's worth 5. If a square appears above the line, this line's value increases by 1. If it falls below this line, it decreases by 1. And so the task here is to maintain what the value of each of these lines are. So it's 5, 5, 6. Then let's say a square would appear here, then it would be 4, 5, 6. So, and apparently this happens very rapidly. So they rapidly change, this changes rapidly in a random order, and so you have to keep track of what those values of those 3 lines are. What Hicks, Foster, and Engle discovered in this development of this online working memory lab is that their online participants were actually cheating, because they discovered that they weren't getting the relationships that they expected. And so they were interested in why that is, and they asked some of their participants, and they fessed up to having been writing down the letters that go along with those span tasks, so the reading span and the operation span. So they came up with 2 very clever alternatives, the picture span and the Klingon span. And I absolutely think this is one of the most clever things I've seen. So in the picture span, similar to the operation span, they have to do the math problem. Is that correct or is it false? And then they get a picture. And so then they have to assemble the order of the pictures that were presented. And so figure out which pictures were presented and what order they were in. So it would be apple, then if there was a cup and a plane, a star, all of these different kinds of images. The Klingon span is also very clever. These are obviously unique visual representations. These are letters from the Klingon alphabet. And so what they've done in this task is you have to remember these really unique symbols. Not very many people know what they are. I certainly don't, even though I'm a big Star Trek fan. So this again provides a pretty unique way to measure this kind of operation span with something participants can't just jot down as they're moving along. And so pretty clever way in which they've done that, and in fact they found that these types of tasks solved that problem, and so they were able to use these as an online working memory measure. So really, really great work by Hicks, Foster, and Engle. Really impressive. So those are the complex span tasks. Another very common task used in working memory is called an N-back task, and these are often used in neuroscience research. And in this kind of task, participants are asked to report whether an item currently presented matches an item that had been presented n items back. So it might be 0 items back, 1 item back, 2 items back, 3 items back, etc. So in a 2-back task, the participant must decide if an item is the same as 2 items ago. So it looks something like this. So this is an object 2-back task. So does it match back 1, 2? Yes. Here the answer would be no. Here the answer would be no. So as these pictures are rolling by, you guess no judgments as they come by. In this kind of 2-back condition, these letters are being presented, and then here you can see the H matches 2-back. It's the same letter. They may have to be making an upper or lowercase judgment in this case. So is it exactly the same? Then this is 2-back, it's different. This is 2-back, it's different. This is 2-back, it's similar, etc. So that's a 2-back task. It's important to understand that these tests test different aspects of working memory. The NBAC tasks appear to be most useful for neuroscience research. They're very good at helping us determine in things like functional magnetic resonance imaging studies, event-related potential studies, what's going on in this kind of working memory task. The complex spans seem to be better at understanding how working memory capacity is related to other psychological variables. So if you're designing a study in which you're interested in the relationship between working memory capacity and some other variable, it's probably best to use one of the operation span tasks. And we'll talk about why you may even want to include some other kind of task, like a fluid intelligence task, to try to pick this all apart completely here in a minute. But that's a little bit about how we measure working memory capacity. Now, it's important to understand that working memory capacity is a really powerful predictor of behavior using these complex span tasks. And so I want to talk first about its relationship with fluid intelligence, some of the research showing relationships with reading comprehension and verbal ability, talk about even some potential for working memory capacity to be related to drug use and addiction, and then finally revisit this question as to whether or not it's really working memory capacity in these studies by revisiting the original idea about attentional control we talked about previously. And this is a brand new paper from Randy Engle where he talks about, and I'll quote the paper here, about how he sees this relationship with working memory and fluid intelligence. So fluid intelligence involves the ability to identify patterns and relationships that underpin novel problems and to extrapolate those findings using logic. So measures of fluid intelligence are things like matrix reasoning tasks, like Raven's progressive matrices, what's called the paper folding task, and we'll look at both of these here in a minute. In the paper folding task, you're to imagine what if you folded a paper a certain way and then punched a hole in it and then unfolded the paper, what would it look like? And then in series extrapolation, you extrapolate out and extend a series. Fluid intelligence then is about problem solving and working with information on hypothesis testing, trying to determine whether or not information, what you've decided is correct or not. So essentially you have to remember what you've tried, determine if that was correct or not, and then toss aside and essentially remember that you tossed aside a hypothesis because you don't want to test that hypothesis again. So you'll see what I'm talking about here with Raven's progressive matrices. The task here is to determine what goes in this particular location. So you have to look at how these are related to one another. Sometimes progression goes across, sometimes it goes down, sometimes it goes both directions. So trying to figure out what the relationship amongst these stimuli is. And so you have to test things out. So for example, it might be that this line is moving upward. We can see that's not happening. So you have to sort of test out hypotheses, and I have to confess I didn't look that closely at this when I put it in. But you can spend some time looking at how these progress, and so then you have to determine by testing out each of these alternatives as to whether or not they might fit in this location. So this is a kind of progressive matrix task. Paper folding task is a similar idea, and so you kind of have to test out hypotheses. It's also more visual, certainly. So in this case we would think, so we have a piece of paper, we're going to fold it this direction, and then we're going to fold it this direction to end up with this, and then we're going to punch these three holes in it and figure out which one of these is the correct version unfolded. And this one's pretty simple. It's this one right here. So as you unfold it, as you unfold this, you end up with this stimulus, and then when you fold that the other direction, you end up with its mirror on this side. And then finally, series extrapolations, you would have to figure out what are the next two numbers in this series. So it's 9, 7, 4, 5. Well, what's the relationship here? So it turns out we're counting down by 2s, 9, 7, 5, and up by 2s, 2, 4, 6, 3. So this would be 6, this would be 3, then it would be 8, then it would be 1, etc. So basically trying to reason out what the solution is. And there is a great deal of relationship between working memory span and a general, what we call GF, or general fluid intelligence. So they did all of these, plus they did this thing called form boards, where you were given parts to put together to create a shape. And I couldn't find a good picture of that online. But that's one of these contributors to this general fluid intelligence. And so these picture span, Klingon span, and symmetry spans were quite predictive of general fluid intelligence at the 0.85 level. And that's pretty good predictive factor there. It's a great deal of shared variance. We've also seen in previous studies that working memory capacity is a powerful predictor of behavior in things like reading comprehension and verbal ability. So people with high levels of working memory capacity are better at reading comprehension tasks. They're also better at verbal ability. So for example, in generating category members under cognitive load, so if they're asked to generate a bunch of animals, then they will, do cougar, giraffe, cow, dog, cat, chicken, on and on. And people with a high working memory capacity are able to do that. And one of the things they have to do is remember what they've said before. And so again, this requires sort of holding on information. And also we can see in people who are trying to acquire a second language or a third language, people with higher levels of working memory capacity tend to be better at that kind of task. Interestingly, there's some speculation about drug use and other addictive type behaviors or compulsive types of behavior in its relationship with working memory capacity. So what we see is that reduced working memory capacity and executive functions are associated with what we call increased incentive salience for artificial rewards such as drugs and alcohol, and decreased incentive salience for natural rewards. What this tells us is that those external environmental cues and ways and things that we are incentivized to go out and get, people with high working memory capacity are better at ignoring or inhibiting sort of the siren song of those artificial rewards. People with low working memory capacity or low executive functions are less able to control that behavior. And so that incentive salience refers to the degree to which an environmental cue will provide a cue towards a behavior and an incentivized behavior. And so what happens is in people with low working memory capacity, things in their environment that cue them to use drugs are much more likely to lead them to use drugs because they can't inhibit them or ignore them as well. And that's, again, an executive function task. So essentially, individuals with reduced working memory capacity are less capable of inhibiting drug-related cues in the environment and are more likely to continue using drugs due to this effect. This raises an important question. If we conduct working memory training, would this be an effective way for treating substance abuse disorders? And interestingly, people with high working memory capacity are much more likely to be successful in treatment for addiction than people with low working memory capacity. So there is some relationship here. The question is, what is that relationship? And we'll have to think about that a bit here in a moment, because there are some issues with working memory and its relationship with things like fluid intelligence that we need to tease apart. So that's where we arrive at this question. Is it really working memory capacity in all of these studies, or is it something to do with attentional control or executive attention? So recent evidence indicates that many of the covariates of working memory capacity are actually related to fluid intelligence. And this is some really important work as well. So if we look here, it looks very similar. This is a regression model, a type of regression model, looking at the relationships between our working memory capacity tasks and our general fluid intelligence tasks and something like reading comprehension. And what we see is once we account for both, that is, essentially we've partialed out the effect of working memory, we've accounted for this relationship between working memory capacity and general fluid intelligence, we see that what's left is a relationship between general fluid intelligence and reading comprehension and no relationship with working memory capacity. So it is through general fluid intelligence that working memory capacity is predicting reading comprehension. So it's not working memory capacity at all. It's actually fluid intelligence that's predicting reading comprehension. we are just able to predict reading comprehension with working memory capacity because it is so related to general fluid intelligence. And so essentially we call this the third variable problem. So while there may have been a significant correlation between working memory capacity and reading comprehension, the causal variable, underlying causal variable, is actually general fluid intelligence. That's really important because if we can improve working memory capacity, we're going to do nothing to improve reading comprehension. And in fact, that's what a number of people have found, that improving working memory capacity does not improve general fluid intelligence and doesn't improve things like reading comprehension. So where does that leave us? Well, according to Engle, he says that he now thinks that tasks used to measure working memory capacity largely reflect an ability to maintain information in the sort of maelstrom of divergent thought. And one of the things I've been recently talking with my students about is when we're under a great deal of stress, we oftentimes lose working memory capacity because of biological reasons we'll talk about in the next lecture, but also because of intrusive thoughts. And so one of the things that happens is if we're under stress, we can't ignore those things that are trying to intrude on our current thinking, that sort of maelstrom of divergent thought. Now, it's a really interesting way of putting that. He goes on then to say that tasks measuring fluid intelligence largely reflect the converse of that, the ability to think of something that may be important at the moment. When it proves to be unimportant or wrong, to disengage or unbind that information and to functionally forget it. So essentially, that didn't work, toss it aside. Both abilities, according to Engle, rely on the ability to control attention to do the mental work necessary to either maintain or to disengage from information. So that's something we really need to think about in terms of how working memory capacity is related to this question of executive attention. And so when people start talking about are they able to improve working memory capacity, which there's been moderate success in, we see that this improvement does not include increases in fluid intelligence. So it will be critical to determine exactly what variables are associated with this improvement in capacity of working memory and not fluid intelligence or executive attention. So is it, if you improve working memory, are you improving anything else? Or is it that executive attention that we need to focus on? Because it seems to be underlying both working memory and fluid intelligence. And so maybe we need to refocus a bit and think about how to improve executive attention. We're going to talk about ways in which we might look at improving working memory in the next lecture, because some of those involve biological interventions like the drug modafinil or transcranial direct stimulation. So we're going to leave it at that, and then in our next lecture we're going to pick up on talking about the neurobiology of working memory.